All right, this is Chapter 5, Section 2. Now we're going to compound interest. Before we did simple interest, this is the simple interest formula here, and this is the compound interest formula. What you'll notice is the only thing that's different is this little n right here, which is the number of compounds. So if n is 1, that's annual, which means it's only compounded once a year, right? And you notice if you put a 1 into this formula, it becomes this formula, correct? Right? So these are the typical compounds you would come across, which is semi, which is twice a year, quarterly, which is 4 times a year, which deals with a lot of taxes. Taxes are paid twice or 4 times a year. And then you have monthly, 12 months in a year, weekly, 52 weeks in a year, and then daily, 365 times. So those are the common ones. Those aren't the only ones, but these are the common ones, essentially. All right, so I'm going to copy this formula. So these letters all mean the same thing as the simple interest. The only difference is the n for the number of compounds. Okay, so I'm going to paste it here, and I'll make this blue, format color blue, and put it equals. Okay, so if you read the problem here, this one is $8,000 interest and will account for 6 years, is compounded 7% per year. So I'm going to copy this down to here. This one is the same thing, but now it's compounded monthly. And I paste this one down here. This one is compounded weekly. So I'm going to move this up a little bit, actually. So it's the same problem all 3 times, except you got per year, which means 1 compound, essentially, per year, right? So n is 1. Compounded monthly, which is 12, and then weekly is 52, correct? All right, so let's do these in this here. So this is 8,000, parentheses, 1 plus, oop, that's not parentheses, sorry, parentheses, 1 plus. So the interest rate is 7%, so 0.07. The number of compounds is 1, since it's per year. There's only 1 compound per year. And then be 1 times, oops, I didn't do the times 6, since it's 6 years. Okay? And then this never works out nicely, so I'm going to put approximate. All right, I'm going to copy this and go down to the next one. And if I read the next one, it says monthly, so I'm going to change the number of compounds to 12. And then the next problem, if I scroll down, this one says weekly, so I'm going to change this to 52 compounds for weekly. All right, so you see it's the same thing. So the question is, what happens as you increase the number of compounds for the same loan? So the loan is 6 years and $8,000 borrowed. Every single time. The only thing I'm changing is the number of compounds. It's always 7% per year, right? So your monthly compounds might like be your mortgage or your credit card, right? Weekly might be like a payday loan or something like that. Okay, so let's put this into the spreadsheet. So I'm going to, where's my spreadsheet? Right there. So I'm going to rename this tab right here. I'm going to right-click and rename this as 5-1. I'm going to hit the plus, and then rename this 5-2 for the second tab, and then blow this up. And I'm going to do A equals, and A equals for all 3 of these. And then shift these to the right. Okay, so there's my 5-2, right? So 5-1 from last time, 5-2 for this time. Okay, so if I go back to my sheet here, I want to do 8,000 and then 1 plus the interest over 1 to the 1 to the 6. Okay, so equals 8,000 times parentheses 1 plus, right, and then I have 0.07 divided by 1, I believe. Let me double check that. Was it 7%? It was 7%, then to the power of 1 to 6. Okay, so to the power of parentheses 1 times 6. You don't need the parentheses if you just do 1 times 6 in your head and put it, but if you don't, otherwise you need to put the parentheses. Okay, so that's what I get. So and we can expand the box out to get more decimals, right? So the next one is 8,000 times parentheses 1 plus 0.07 divided by 12, right? Wasn't it monthly? Yes, 12 for monthly. And then, let's go back to that, close paren, to the power of 12 times 6. You need the parentheses unless you actually figure out 12 times 6, which is what, 72, right? So either put 72 or put the parentheses around the multiplication. And that's the amount we get there, which is a little bit different of amount, correct? And then 8,000 times parentheses 1 plus 0.07 divided by, was it weekly? 52, I believe. Wasn't it weekly? Yes, it was weekly. And then parentheses, so the power of, parentheses, 52 times 6 years, right? Yes, 6 years. Okay, and again, if you do 52 times 6 in your head and put the number, that's fine. Otherwise, put parentheses around it, so it's the power of all of that, right? And you see the amount, as we increase the number of compounds, the cost of this loan, or if it's a savings account, the amount that you're making is increasing, okay? So let's put these amounts in now. Let me just double check. So we have 584, 84.4, 28. Okay, let's go like, I don't know, 4 decimal places, I guess will be fine. 2540. All right, I had to memorize what they were here. So this first one is a dollar amount of 12,000 and 005.8428 ... Format color orange. Okay. The next one is dollar amount 12,160.8440 ... And the last one was dollar amount 12,172.2540 ... All right, hopefully I got that right. Trying to remember what they were from one tab to the other. Okay, so in general, as you increase the number of compounds, it's going to increase the cost, right? That's typically why they want to compound. So 7% is not really 7%, because it's unless it's actual per year with one compound, essentially. All right, that's the end of part 1.